Mark, we've talked a little bit about the different forms of selenium versus inorganic and organic and their different bioavailability and toxicity issues. But what is the biochemical role of selenium in general?
That is a frequently asked question in terms of what is the biochemical role of selenium.
Mm-hmm.
To explain what the biochemical role of selenium is, one has to understand what free radicals are. And to understand what free radicals are and why they're harmful to us and to the cells in our body, one really needs to go back to a little bit of basic chemistry. Basically, an atom is the smallest possible particle matter that exists. It can't be divided any further, and it can't be seen by the naked eye.
Mm-hmm.
A good example, a molecule of water.
Okay.
A molecule of water has 2 hydrogen atoms and 1 oxygen atom. That's why it's also known chemically as H2O.
H2O.
And those atoms are so small, those 2 hydrogen atoms and the oxygen atom, you can't see them with the naked eye. In terms of one atom, you can see the molecule of water in the water itself, but the actual individual atoms, you can't see them. They can't be divided any further. But an atom has a very dense nucleus.
The center.
Right, the center of it. Almost kind of think of the planet Saturn.
Okay.
So it's got this very dense nucleus.
Okay.
And that's positive, and it contains protons, which are positively charged.
Okay.
Now, what surrounds that nucleus of one atom is an electron cloud, and those are negatively charged.
Okay.
And with these negative charged electrons that surround this nucleus, they're all in pairs. Every electron's in pairs, and that's what makes them very stable. And that's why when they flow through our body and they're very stable, people don't have any type of problems whatsoever.
So you've got a positive charged nucleus surrounded by a negatively charged outer ring. And so as we understand, like batteries have a positive end and a negative end. And this atom has much the same thing.
That's correct. That's
okay.
correct. There are some neutrons in that nucleus also, but they're neutrally charged and have no effect between the protons.
So we've got a
electrons.
balance between positive charges and negative charges.
That's correct. But these electrons, what's more important is these electrons are in pairs, and you have to think like 2 wheels on a bicycle.
Okay.
They're very stable when they're in pairs. But there are environmental forces and outside forces that can knock one of those electrons out, almost like knocking a wheel off that bicycle, and it creates a tremendous instability.
Okay.
And when you have that instability, that's when you get a lot of cell damage from those free radicals. And that's what a free radical is. When one of the electrons, when it's not impaired anymore, and it creates that instability.
What are some of those things that would create instability in that atom?
The most common forces that cause free radicals to be produced, or basically to cause one of those electrons to be displaced.
Right.
So therefore you do not have the paired electrons. Some of the most common forces are radiation, overexposure to the sun, stress, alcohol. Some drug treatments also cause that. Environmental pollutants, cigarette smoke. So there's a whole array of environmental factors that can cause those electrons to be.
A lot of those you mentioned are common in everyday life.
Yeah, they are. Even the air we breathe in certain cities, and especially in densely population cities and so on.
So just living everyday life oftentimes can create this instability and these free radicals in our body.
That's correct.